Hello, everyone, and welcome to the webinar. We'll start in just a few moments from now. Thank you.
He present this picture where we can basically see the part programming structure on the Swiss type, where he made basically the very first point on his presentation that was creating operations that was done completely on a main spindle. So in today's webinar, we will make a part programming that where we will show the cutoff operation and also MCO cycles related to the cutoff. Then we will make operations of the back spindle. We will show you a little bit of channel synchronization, part release, and so on. Okay, so let's go into SolidCAM. And the very first thing what I'm going to show you here is it's all the operations that are done in previous webinar. Where you are now. Okay, sorry, it's on another screen I have. All right, here you go. I'll go to the Solid Verify this time. I'll just run the simulation. So we had a couple of the outside diameter turning. We have the face milling from the front. We have inclined milling. We have inclined drilling. We have the wrap operation. And now basically the next operations that I'm going to perform is to do a cutoff here. But before doing a cutoff, we need to bring machine into a state which is actually necessary before making a cutoff operation. So in Swiss type machines, that is basically two things that you have to do. We need to select the cutoff tool and preposition the pot. And the second MCO will be basically bringing the back spindle to the clamp position where it will hold, and basically after that we'll have the cutoff operation. So let's see how to do that. Okay, so for this I will just open the very last operation. Okay, and I can go to my machine preview. I'll just move the operation over here. All right, and open my machine preview over here. Great. And this was my last basically operation, and the tool where we left it, and I can basically update the stock, and here it is. Okay, so now we need to pull out the bar basically out from the guide bush and select the proper tool. As you can note here, because we used on some operations the B-axis is not in the reference position. Now, on some machines, this could be dangerous to leave the B-axis on not reference position before the part transfer is performed. Even though that on this machine it's not that critical, and especially the angle that on which it is now, it's on B170 degrees, so it's not that far from the home reference. It is not necessary to do it, but in this webinar I'll just do it. Okay, so I will just create an MCO. You can create the MCO by doing a right click and add the machine control operation. For all of you who don't know what the machine control operation is, it is basically the operation where we can control all machine functions, which doesn't include the toolpath itself. Okay, it doesn't include the generation of the toolpath. Yes. Another way to create an MCO is by going to the SolidCAM operations, and you will find it over here. You can use both ways, it's completely the same. So click on the MCO. All right, and over here, every post-processor will basically come with the predefined cycles that your particular machine can use. So in this case, I already have the MCOs. Those are all that are predefined. We will go through most of them in this webinar. And they are grouped basically for the part transfer, something on the main spindle. We have the MCOs that are related for the back spindle. We have the retracts or moving to the reference. We have something regarding to the synchronization, part eject, and some other miscellaneous machine functions. So I'm looking for the B-axis move to the reference. And the very first question that it's coming here is, do we like to set the submachine as defined for the particular particular one, since it is the one that is selected over here, it's different from the one that is actually defined inside the cycle itself. So always click yes on this question. All right. In this moment, I don't need to select anything. The default that it's here for the reference tool, it's great. You can basically what you can do, you can go to the machine preview, also in the MCO, that is very nice and important. You can see again the position where it is, and just after clicking on the particular parameter, you can know that the B axis moved to the reference, which is on this case is B90. All right. Now, what is the most important thing before we actually bring all the things to the situation where we can make the cutoff operation? So we need to make sure that our setup is defined correctly. So I'll just go to the setup itself. And as Igor already mentioned, on the main spindle, we have here, he set up the Z on the 70, which is the machining length, necessary length in order to machine one single piece of the part. And for the back spindle, the very important thing is to select the proper MAC. In order to put the proper MAC, you just click on the second icon over here. So this one is the fixture itself. We don't have any fixture over here, and we will just select the part over here and click on the home and select the MAC 2. Great. Now I will go to the machine preview again, and by doing this, I will basically set up the machine, or let's say the back spindle position for the clamping. Yes. So basically, how much the part will be out from the back spindle face. Yes. So in order to see that in the machine preview interface inside the machine setup, it's very necessary to rotate your machine here, so we can see the part here. You need to go to the stocking feature over here. As you can see here, the part is like in the Z0 as it is defined over here, but you can move with the scroll wheel and just basically set up where you want to be when it's actually on the back spindle side. So I'll just choose some like 15 in this case, okay? And SolidCAM will automatically calculate which is the clamping position later on in the MCO. Before leaving the machine preview, don't forget to turn off the stocking by going to the main spindle side and clicking on the stocking. Otherwise, you will have the situation where all the main spindle operations have basically the red box, which means the part is not actually on the main spindle. Yeah. So I'll leave as it is. Now my machine setup is correctly defined, and I'll click OK. Perfect. I will move here. I will add another MCO. I'll click over here now. And the first thing is I will make a part transfer over here. I will use one of those cycles. Basically the one is the Z1 prepositioning, or I would say the bar, how much I want to be in front of the guide bush, and selecting the cutoff tool. Over here you can see there is two different outputs. Basically, it's for the macro and manual. Don't be confused in this. Basically, the only difference is later on in the G-code output. There is the results later on the machine and on the part. Basically, it's the same. It's just the style of the output that will be generated later on. In this case, I'll just use the macro one. And again, the same question will appear like, would you like to use the submachine of the TO1, TO5 on the main spindle? While this one is selected, I will say yes. Perfectly. So here are some other parameters. I will not change anything before I don't click on the machine view. I'll just move this over here on the right. Perfect. So what are the parameters that we have to define over here? So there is the cutoff tool number, which we need to select. As you can see, the tool number 1 is selected, so I can just basically click on it. And as you can see, machine preview automatically updates this position. So tool 1 is selected. All right, the spin, our cutoff spin, so I'll put like 2500. Just put 2500. My X preposition, I will leave the 20 as this machine is SR38, the radius value of 20 will always be correct. You can optimize this. You can change it to smaller value, but in this webinar, I'll just leave it as 20. Now we have the cutoff position. All right, so what is the cutoff position here? So there is something, as you can see, the zero value is defined here. So for the cutoff position here, it will be located over there, right? There is one very nice trick that I really like, very much like to show, is that doing a right click on the cutoff position and doing a pick point. And once you click on the pick point, I can now select where I would like to make a cutoff. The cutoff I would like to do on backside of the part, including also the stock itself, because I want to leave some material, you know, for later on finishing on the backside. So just click on this point over here, and it gives me the value. Now this position, let me just, now once the part is defined, you can note that cutoff position is not correct, since this is here is the tool offset point. So the 2 mm more has to be defined in order to be in correct spot. Now the crucial point on every CAM part is, do you use left hand or right hand tool or on your particular project? So let me go back to the presentation itself, and here I have a few slides that I want to show you the most critical parts regarding to part programming when you have the left hand tool and right hand tools, and basically what are the main differences that you can get. On the left side of the screen, you can see the right hand tool, exactly the same situation that we have now, is that we can perform the cutoff in the basically zero position of the part programming that is over here. Yes. Now there is also the left hand tool, and I would say that I don't know, like at least 80% of the Swiss type parts is done basically by the left hand tool more rather than the right hand tool. And let's see why it's that basically. I'll show the next slide. And let's start basically with the left hand tool. When you have the left hand tool and you bring your back spindle to clamp position, usually it depends from machine to machine. The back spindle can approach maximum to about 2 mm in front of the cutoff tool. So on some machines you can go with 1 mm, but mostly this is like something averagely that can go 2 mm. So what this means is that our part remained on the back spindle can have about 2 mm out of the back spindle itself. While if you see on the right hand tool, when you use it, you're very limited of how much part must be out of the back spindle. As in this case, it depends of the shank width and the insert size. Yes. So conclusion is, if you have very small part to be clamped on the back spindle and it's going out from the back spindle, always use the left hand tool. It will be always good. But if you have pretty long part, doing it with right hand tool could be also possible. All right. Let me go back. So now here I have the right hand tool. Okay. Even though I don't want to do it with a right hand tool, so I'll change it to the left hand tool. So how to do that? I'll just exit from the machine preview. I'll just save and exit here. I'll go to the tool table itself. All right, so we are in the tool number 1 over here. I'll go to the mounting again. Okay. And what I have to do here, I just click on the shank itself, and instead of cutting direction on R, I'll just choose a left one. And I need to move now my insert position on 20. And this depends from machine to machine. On this particular machine, the shank of the cutoff is 20, basically like that. And now this is the left hand cutoff tool. Now, of course, once we change the cutoff insert the position and direction, we'll have to update our cut off position. So I'll just go to the edit here. Make it bigger. Also, by the way, for all of you who don't know about this feature, you have very nice feature over here, like it's focused the target, which by clicking on it, it will zoom to the area where the part is located. I'll go to the parameters now. And now instead of adding the cutoff width, you don't have to do it with the left-hand tool. You just pick a point, select this one, just accept it, and everything will be very good. I'll go to the bottom for the better preview, and here we are. Very, very nice positions. All good. I can go to the expert position. I can change. I can check if my cutoff is correct. As you can see, everything is very perfect and correct. You can also use this axis to play with the values, so to check if you are in correct spot, right? Okay. Now my first MCO in this part transfer process is done. So I'll just click 7 calculate, and I've seen from many people that they will leave basically the machine control interface, and they will just again do a right click over here and just add machine control, or they will go into interface and MCO. What I really like to use is, instead of leaving the MCO, I will just use this 7 copy, which it will create exactly the same copy of my previous operation, but instead of this cycle, I will use another one, which is preposition the back spindle using the Z2 axis and catch the part, basically, yes. So click this, I'll accept that MCO. And the very first parameter here is to say how much in front of the part I would like to be with going with the rapid. In this case, I'll just put 5. And I would just open here so you can all see it. Machine preview, zoom in here. You see the position of the part where we left it with the previous MCO, and we set it here to 5. So I'll click on this parameter. And what you can see here, that we are exactly 5 in front of the part. Now going from rapid preposition to the clamp position, we have a value of setup location. Now, if you correctly defined the setup itself, what I showed just a few moments ago, the SolidCAM will automatically detect where part has to be grabbed or catched. So I'll click on that, and you can note, I'll just rotate it a little bit better so you can see it. You can note that this position is exactly the position that we defined in our machine setup. So basically here, you don't have to change anything. SolidCAM calculates all well. You just pick up that cycle and all is good. You can also use some of the air through the spindle and clamp feed. You can accelerate or decelerate how much he goes from the rapid preposition position towards the clamping position. So I will leave it as it is at this moment. So I'll save and calculate. And I will again click on the new cycle. And this time, I would use the synchronization, where I would like to synchronize my ball spindles together with the Z1 and Z2. Now, this is very necessary, even though that not too many machines have the superimposition in this case, and I would just like to spend a few moments talking about this. Once the back spindle catches the part on the main spindle, it is very necessary to run the spindle synchronization, which means the both spindles must rotate with the same speed and phase in order to perform the cutting. Yes, there is some cases where you want to perform also the additional turning operation, and in that case you have also, once the part is catched, you need to turn on the axis synchronization over Z1 and Z2 axis. In that case, the part can be protruded through the guide bush, and back spindle will basically follow up that position. Those things and details will be later on catched in future webinars, okay? In this case, and in this particular example, we must use this MCO and tell it to SolidCAM that the spindle synchronization it's on, and my Z1 and Z2 it's also turned on. It is a must and default on this particular machine. All right, I'll just save and calculate. As you can see here, we defined 3 MCOs here, and now we are ready to make a cutoff. I'll just do a right click over here. I'll go to the turning and make a cutoff. So there you have it. Also, you can go to the SolidCAM in turning inside the ribbon, and you also have here a cutoff. There's nothing so special about this. I'll just select on solid, make sure that you choose the proper coordinate. Sorry, in this case, we are still on the main spindle, so I'll leave it on Mac 1, position 1. All is good. My start phase is this one. My end phase is the same one. As you can see, the starting direction of my geometry is incorrect, so I'll just change it. I'll just reverse it. I'll click OK. I'll go to modify geometry. You can note that it goes all the way to the updated stock. This blue line over here is the updated stock. But over here, we still have some material, yes? So I'll just go and I'll auto extend it. So make sure that it goes all the way through. I'll click OK. Perfect. My operation name is just a cutoff. Good. I'll select the tool. Tool number 1. Make sure I'm using the same RPMs as I defined it for the back spindle on the MCO. I will not go into the cutting details and the stuff. This is not so much not important. What is very important is the origin position. Origin position of the most of the Swiss type will be on the 0.4 in this case. Which if I bring the machine preview, I'll just click it over here. All is good. I'll go to the levels. Nothing I will change. Technology, everything is well for the default, except of the offset. So I cannot remain the offset of 0. I need to leave it for 25, or I think it's 0.5 defined on this CAM part, sorry. I'll go to the link, and I think this is the most critical part on every Swiss type machine. For the approach point, we will use only X, and on the diameter, since we use the radial value of 20 there inside the MCO, that's on the X diameter, it's 40. And for the retract point, it is the most critical part of the cutoff, is that you cannot use to the right safety corner or anything else except of the none. So the none must be used. So the thing that we want to achieve with this is that once the cutoff is performed, the cutoff leaves at that place, and later on we will see once we enter to the channel synchronization that this will be also a starting point for the next part. Okay, so the cutoff should not go to retract, but it should remain to none, and this is a must on the Swiss type. All right, perfect. I think I didn't forget anything here. All is good. I'll just save and exit. And after we perform the cutoff, we have the group of the MCOs, as you saw it in the slide, that we have some MCOs that is also related to the cutoff operation. I mean, after the cutoff operation. So I'll just add another machine control operations, and in this case, it will be spindle 1, spindle 2 off. I'll just calculate. I will add another MCO. I will just go over here and select part move after cutoff. Nothing there to check except of that there is going to the reference. So let me show you this. There's the machine preview. We are over here. As you can see here, we are in the cutoff end position. And after clicking on this, you can see that my part is now located on my backside. So this is almost the last MCO operation. I'll just calculate. And last but not least is another MCO that is program end with bar exchange. This is also the last MCO that will be available after you generate the G code. And I will talk about that also later on after we join to the channel synchronization itself. I'll save and calculate. And we are basically done. Now, of course, you can see that we lose some time in order to generate like 4 MCO before the cutoff, 3 MCO after the cutoff operation itself. You don't have to do these operations all the time. Yes, because of this, you can do a right click over here and create a template. The template will store all those operations. Let me just bring it over here. And you can name it as I did it already here just before. You can just name like star, SR38. I will say in this case another cutoff. And I'll just include the tool data, include geometry filter, and just click OK. Later on, you can just use this and just insert and paste those operations, and in order to minimize the programming time for this part. Okay. This will speed up the things for sure. Okay. And now the very few operations on the backside. Usually the backside it's always more simpler, but I will show you very nice options in SolidCAM to handle some of the stuff in the Swiss type, especially on this kind of geometries. And let me just create a face turning here. And before I do that, I will just create a tool. I will just jump to the part tool table. I'll go to the mounting. Right. So we have here something that we called also the back tool post. It includes 8 tools over here that can mount also the turning, also the milling operation. Milling tools. And it is very good practice to put the turning tool on the very first over here, or the one on the bottom. Yes. So I will add few tools for the milling, for the turning, and also for the drilling. Okay. Before I start with creating the operations. And I will start with tool number 21 for the turning. And as you can see that none of those positions have the holder itself. I already prepared the holders. It is located, let me just show it to you here. I already prepared it. You will also get it together with this part. And basically, I will just insert the new holders, STL holders itself. So I will go to the SolidCAM part, and you can find in tool library options, you can find tool STL holders, or you can go to the tools SolidCAM tool library, and you can find it also over here. Okay, great. So I have the holders, and my best practice is I always do a right click, and I am adding the folder. And here I will just say star SR38, and I'll insert all the holders that I'm using on this particular machine, and just add a STL holder. Here we are. I'll use this one. It's the right hand for using the insert VCGT. I'll just open it. When I export it, I use this coordinate system over here. And what I have to define it is the holder mounting point, which is the red dot over here. And there is a blue point, it's the tool mounting point. In this case, it is not visible since it is behind the holder mounting point. But if you try to move it with the scroll wheel, you can actually be able to see it. So I'll just go to I think it's the front view. I'll try to position this point closest to here. Of course, you can do it in different way. You can measure it. You can get it from the catalog. I'll just do it like this. Something. I think this one it's fine. 22, 53. I think this is fine. I can also change it later on. Good. I'll just save it. I will add another STL holder. This one will be for the milling and also drilling tools. And which one it is? It's for the ER16. I'll just open it. Right. Here it is. Tool mounting point on X or the X is 0. On the Z, it's, let me just, roughly this will be perfect. So -50. Cool. This is all what I need for this part. So I'll save and exit. And I'll go back to my tool table. And I'll define the new turning tool. It will be external turning. I'll go to the mounting immediately. Great. I would like to put it on T21. So immediately I would just move it to T21 for the turn. Since I will change the 2100 here, I will just go to the holder. I will just use the global, and now you can see that our holder folder is available over here. So I'll just select this one. Now, because we have the insert here, let me just change the insert. So was this one, and I'll show you now BCGT. I will show you one very nice trick. Inside the topology, you can go to the insert and just like VCGT type it, and SolidCAM will automatically change this for you. Yeah, I really like this feature. Of course, we have here the checkbox insert only. Change my position to 0, 0 since we insert it correctly. And my lead here will be 5 degrees actually. Sorry, maybe I just change it. Okay, now this is just use the Z plus. It will lead correct thing. The only thing I can change is the diameter size of the insert basically. So it's the D. I'll use the 11 here. This looks good, but like I said, you can also change the position on the X, for instance, in this case, like -2 here and maybe more here. And I think this one it's let's say fair and good. Yeah. So I'll leave it as it is here. All good. I'll save it. I will just add another milling tool. Let me add one end mill. I'll use the number 8 in this case, or maybe I can use also the 6, or it doesn't matter. And I will leave the outside, it's 35. I will use the holder of the STL. I'll go to the global. I will use the milling one over here. That's it. It is along the Z. I will not use the T22. It will be on the T21, T28 of the milling. And it will be on the 24 in this case. I really like to show you one of the features, even if I put the tool over here, yes. And I would, in this case, change 2400, and I'll copy this tool. And I will put it on, let's say, 26. And I'll say 2600. The type of the tool, I will change tool type to, let's say, drill. And my diameter, since I have 2 diameters over here, I'll just check on the diameter here. I'll click on this surface, and he'll select it's 5. I really like this feature. And I'll just copy again. And instead of 26, I'll put on 27. All right. 27 over here. And this diameter, it's a little bit smaller. I think it's 4. Exactly, it's 4. The positions, the outside holder, it's not correct. It should be 35. And also for the 24 here, let me double check it. 35, this is correct. And 26, it should be 35. I'll just roughly put it on the same distance over here. Yes. So I have all necessary tools in order to finish the part programming on a backside. So I'll just save and exit. And there's no so special things here. I will just do the face turning over here, outside turning over there. And also we will make the milling of the hexagon and 2 the ring operations. Okay, so I'll just highlight the features that I like in the most. So I'll just go to the face turning. I will just now select the Mach 2 position 1, and I'll say face on back spindle. I really like to be also organized. I'll click on new. and select twice over here. I can also select the counterclockwise and just accept it. Again, I will extend the geometry. Great. I'll go to the tool and select the tool. We say 21. I'll just double click and the tool is selected. All right, now I'll go to the preview. I'll show you something very interesting. This is very common on the old Swiss type machines with the back spindle and turning. I'll go to the top view and I will zoom in here. So what we have here is the part itself with a coordinate system over here. As you can see, X positive here, Z here. And we have the turning tool over here. What you can note that insert position is basically coming and approaching, should approach to the X direction, but in negative, as you can see it over here, right? So how to do that? Usually the Swiss type customers like to not machine not to put the insert into this direction, since you can have here more tools available, and because of that you will have no enough space to turn this part, or maybe to do outside diameter turning. And because of that, it is more practical to put the insert in this area, so you have enough space to do all outside diameter turning machining or turning itself. So I will, in this case, just 7 calculate, okay? And what will happen is, let me go here. I will just calculate something wrongly, of course. But what is happening is that we are doing everything from the face like this, which is wrong. So I'll go to the technology. I would say, face. I'll go to the rough. I will say here, not roughing. I'll just make a finishing only. I'll just go entire geometry. My link, it will be from right, also from the right. Good. Now I'll save and calculate. That's better. But as you can note here, the insert itself, SolidCAM will generate a toolpath which will basically which is basically allowed by insert. So it will go in this direction, really slowly allowing the insert by the 5 degrees of angle to finish this geometry. Yes, but this is not correct. We would like to actually approach from the X negative position. And this is a very nice feature that you can go to the tool itself, and here you have the X negative. Once you click on this, you can note the spin direction automatically changed. You can also see it in the interface. After we click on 7 calculate, the direction will be changed, and also the position of the insert will be changed. I will just move this a little bit, and you can see also the toolpath now. It's available and it is located on the negative side of the coordinate system. So this is a very nice feature. And also, if you generate now the G code, I'll just generate the G code, click OK. Let me just show you here. All right, let me just move it over here so you can also see it. So what we have here now is the output that gives us X negative, yes? So this is a very important feature that I have regarding to the turning, doing it on the back side, yes? And also the customer itself, you don't need to worry about spin direction. It is automatically handled by the post-processor itself. And also you can see it here in the interface, yes? Right. The next operation is just OD turning. I will just use the 7 copy. I would say OD turn on back spindle. I'll just change the geometry. I'll just select from here to here. All is good. I'll just make sure that I extend everything. So I'll just extend and extend. I will accept it. I'll go to technology, and this time I'll just like to do a rough from long external, maybe down step of 2, maybe put something on X and Z, semi-finish, entire geometry, I think that's basically it, and nothing to worry more about that. Yes. So let's see the toolpath. Looks good to me. All is good. Yeah. Great. Next, the next, I would like to perform this hexagon. And on many Swiss type machines, mostly you will do this with a C-axis, because on the back spindle, most of the machines doesn't have the Y-axis. If your machine configuration have the Y-axis, then you can also perform it with Y-axis. I will definitely recommend to always use the C-axis in this case. So let's see how to do that on this. This basically similar with a main spindle, with a one very nice feature that again I want to show you. So I'll just do a right click here, add a milling operation, and this time I will just add a profile. I will use Mach 2, position 1. I'll just click new, and I will start from this side, and I'll just select the complete profile on the same level. I can also use some of the filters and select everything automatically. Now we have complete chain. I'll just click OK. I'll change the operation name to like XZC, milling, also back spindle. I'll select the tool. And now this is the very interesting part. I'll just select, go to the mounting. And the tool that I prepare for this is the tool number 24. Let me just select it, this one here. Great. I'll go to the levels. I'll not define anything so special here. I'll just select the upper level, the profile depth over here, this one. Inside technology, yes, I can use the finishing. Pardon. Links, I'll just perform with a distance here, maybe 60 degrees. SAM is leading, and just the L7 calculate. All right, so we approach here. We'll do all the way around, but I would just like to do it with my fourth axis, from the face, polar, using the cycle of 12.1 on this machine. Nothing else more to check. The SolidCAM will automatically interpolate the C-axis, and all will be good. But now what you can see here is the very common situation that many Swiss type customers face off, especially when you have the tool over here, is that in this case, we can already predict with machine preview that the back spindle will hit the part release element over here, as you can see it in this case, yes? So I'll just 7 calculate, and we will later on see that in simulation. And what the feature that I want to show you over here, I'll just 7 copy operation, and I'll show you that the same strategy, same toolpath can be applied basically from the X negative direction. In this case, I'll just change operation name to XCC, maybe negative. And to change that behavior, you go to the tool itself, and here we have the output according to. And before I change it over here, I would just like to show you. You can see the machine preview. I will just jump with the tool. Here we are. And instead of CX plus, I will use CX minus and 7 calculate. And now this is a situation and position where we can actually mill it here without any problems. Yes, so this is very nice feature, and it is not only when you can hit here with a part release, but also when you have other tools here available, the neighbor tools. If they are longer or so, you can basically, it is very important that we can control X negative and positive either in turning, either in milling operations. All right, I'll just exit here, and basically the next operations is just those 2 drillings, nothing so special, and I will not define it in this webinar. They are not so important. The very next step is that is very crucial, is the part release. After you complete all the operations on the main spindle together with the part transfer and then the back spindle operations, it is very important to create a part release. Let me go to the presentation. As you can see here, we have a part release. This is very critical MCO since it shows and present to the software where the part is now released from the machine itself in order to be able to define the part machining continually. Okay, so where we can overlap the operations on the main and back spindle. So how to do that? Again, it's very simple, just one MCO. So let's go to the SolidCAM operations. Let's add an MCO. And you can click over here and you can see the part eject. I just select yes. I'll go again to the part machine preview. Here we are where we left off. And now we have part eject position. So we have some default value. So I'll just click on it and you can see the part eject position over here. So we can optimize this. If we leave the value as it is, probably the part can stuck here or not correctly fall down. So you can just basically click on these three dots over here and you can just put into position which you want. I think 65 will be completely fine. Yes, this is completely good. I'll click OK. All the rest, well, of 1 second is okay. Use the air there, it's by default. I'll just save and calculate. Perfect. And here we are. So we completely define all the operations. On the main spindle side, we make the MCOs, we make the cutoff, we made another MCOs, we define all the operations on the back side. And the last step in the part programming, basically it's the channel synchronization and generate a G code for your machine, okay? To make a channel synchronization, maybe you remember in some of the previous webinar, we mentioned that every Swiss type machine with the main and back spindle runs a main and back spindle simultaneously. Yes. So basically, what you can see in the part machining is that main and back spindle works at the same time. To make such a simulation and G code generation. In SolidCAM, we are using the model of channel synchronization. Let me show you where it is. So you can click on the particular setup itself, do a right click, and go to the channel synchronization. Or you can just simply click on the channel synchronization over here in the ribbon. All right, so let me move it over here. And I will just increase the size a little bit. Okay, and what I really like to do, I just like to click this show all and then click on actual size. So I can see all the operations over here. I'll just delete all the labels and I'll just very quickly explain you what we have in our interface. So we'll start from the top left. We have three first icons that allows us to synchronize two selected jobs. They are now not they're now gray because we didn't select anything, but if I select two operations, they will be available, as you can see it over here. Then the fourth icon, it's synchronized all operations in the country order. So basically the status that you can see right now, it's the simulation, as you can see the country order. So we define all the operations in main spindle, then we have the MCOs and then the back spindle, yeah? Cool. Then we have the insert all the labels for all operations. I'll talk about that feature later on. We have insert on a new workpiece. So basically, this is the most important feature on the multi-channel builder machines. I'll talk about that in very few moments. We have deleting the labels. We have showing the operation duration. We can see everything in time frame view. We have the clash view. The clash view is the very smart system that allows us to, that guides us towards the solution. So basically, if we have defined something that it's not correct to do, for instance, I would like to make this MCO bar program end with the bar exchange, which is obviously over here. And if I try to do it before it is defined in the channel, let me just delete this. You can know that I'm trying to make some operations together with that MCO, which is not physically possible. Yes. So in that case, the simulation and the G code will be basically not available. And as you can see, I'm clicking over here, but it's not possible to do it. And also then we will see the operation clash view. I can just click on that and he will highlight all the operations that are not correct, showing you, okay, this operation can be executed simultaneously during the CAM tree or the instruction. Okay, so very good time to show this undo and reload button. So I'll just undo it. Very nice feature. And we can also at any time export the current status of our channel synchronization. So that's very nice. So I can just say this is a default. This is a default, and later on I can export, our final results. Great. As you can see here, we have total machining time of 6 minutes and 24 seconds, or I would say like 6.5 minutes. Okay, so let me go to the presentation very quickly. And this is what we have basically with our programming. We have main spindle operation and so on. We have cutoff, we have back spindle, and we have part release. Okay, so we have machining time before synchronization, which in our part case, it's 6.5 minutes, okay? So the goal of the channel synchronization is to minimize the machining time per part. On the Swiss type example, what we are trying to achieve is to run in parallel jobs on the main spindle and on the back spindle as far as that possible, and by that minimize the machining time. To do that, we are using the feature that I showed you. It's called add new workpiece. In general, this means where you would like to cut your program. Okay, and in this case, it is in the practical situation, the customers on the Swiss time machines usually select the very first operation on the back spindle. Yes, so we will use this feature, and we'll basically kind of split our G code or our program over here. And as you can see, that it is removed over here, so from the main spindle operations. And then we will move it and synchronize it with the main spindle operations. And by doing that, we'll minimize the cutting of this, will minimize the cycle time for this part, which is obviously much shorter. So this is the idea that we are going to do in the next step of the channel synchronization. So let me just jump there. So let's try to do that. So what is necessary? I'll just select very first operation over here. Yes, by the way, a very important thing before we continue, we have here these black marks over here, all the way through the channel synchronization. These are the weight marks. It's very popular called weight marks or the weight codes. They all have the number itself. And basically, once you print the G code, the only way how the tool paths communicate, it's by reading those weight marks. So what we have in this situation is that the G code will be generated with those operations on the left, as it's called also the path 1. And we also have another G code that will be generated, which is called for the path 2. And in this case, what it means that we will run the two G codes completely together with the label or the weight mark that is called 210, and they will start all together. As on the path 2, there is nothing here. The machine will basically stop and wait until this number is reached. So all the operation it's going, and another machine basically stop on this number until the main spindle or the path 1 don't reach the same label number. So this is in basics how those machines communicate between two toolpaths. Okay. So what we are going to do now, again, coming back to adding the new workpiece. It's by selecting the very first operation on the backside, and I'll just do right click and add a new workpiece. You can also do this by clicking on this icon, add a new workpiece. And what will happen is that all operations, so we still have here 6 minutes and 6.5 minutes, but all my operations that were at the bottom, we literally cut it and just move it on the top. But now what we are able to do is we can basically remove this label, just doing a right click and delete the label, or I can select all operations over here. I can just take it and drag it here to this label. As you can see now, we have all operations on the main spindle synchronized with operations on the back spindle. And what is very important, we can simulate the G code. We can simulate the operations and we can generate the G code. So for the end, I would just like to run the simulation. I'll just go to the machine simulation and fully simulate hold the process.
And by the way, you also see that the machining time is now also cut down to 3 minutes and 51 seconds.
Exactly. Exactly. So this is the main goal of the channel synchronization. Very, very, very good point, Sydney.
Thank you.
What is very good here in the channel synchronization, if you run the simulation through the channel synchronization, it will still leave the channel synchronization window open, which is very good and practical, especially if you have two screens. So you can basically take this window and basically move it to the left side or right side, right screen. But even if you don't like to do any of those, you can basically close it, but it will not close the simulation itself. To make it run, I will increase the space of this simulation by doing a right click in the ribbon, and I like to turn off sometimes this use large buttons here. So in that way I can increase a little bit the space, and I'll just move this over here. Great. I'll go to the move list, and what we can see in the move list is all the operations that are on the left, and you can see this 2 equal sign with the operations that are on the back side. By this, you can see what operations runs in parallel, okay? What will be focused here, in the previous webinar, we saw all the operations on the main spindle side, and we will be mainly focused on the back spindle side, yes? So I'll just move the simulation over here. I'll just run the simulation. Here you go. As you can see, the operation starts on the back side with a face turning, outside diameter turning here, very nicely. Then what we have here, I think I turned it off here, the collision check, is that we have here the collision with the main side, even though we run everything with the C-axis here. And then we go to another side, which we are completely collision free. And I will now slow down here just for a moment, because here we have the part release, and I would just like to show you that as well, because it's exactly what we've seen in the simulation. In any time we can make a pause here, and then I can go to the part eject, and just by clicking on it on this, and I can now continue with the simulation. So I'll just run it. Here we go. We leave it, and now we have part. He waits for all operations to be done on the main spindle side, and the wait code prevents the back spindle to continue for the part transfer until all operations are done on the main side. We don't have to wait all this, as it is already simulated in previous webinar. So I'll just go over here and click on the B axis to the reference. All toolpath will still be verified, okay? So jumping to another operation doesn't mean that you actually will skip all the collision check. It will all be checked. And now let's see the simulation. I'll just run it. We'll go with a B to the 0. All right. Z1 to the preposition state. Selecting the tool. Back spindle is coming to the C0, C2 0 as well. And approaching. Of course, this can be very fastly simulated, but for the presentation purpose, I just leave it as it is. We're coming to the clamp position. Make a cutoff. In this moment, I would just like to stop it. Here we have remain bar. We could also leave the longer stock over here, so everything will be very nicely simulated. In this case, I didn't do it, but basically you can imagine here the bar left at this position. In the stock, it's in X negative. And the remaining stock, as you can see, travels with the back spindle itself. And with this, we completed the cycle of machining of one part. Okay, I'll just leave this, and once all Twopart is verified, you can generate a G code. There's nothing easier to do that in SolidCAM just by clicking on G code over here. I'll click OK. The G code generation is on another screen. I'll just reload it, and here we have it. All the G code for the back spindle. I'll just like to show you a few of those that we have for the negative XZC, which we start on the X negative here. We have preposition for the part catch. You remember 5 mm in front of the part, so here it is. And we have also the main spindle side with all variables necessary for the machining, and all the operations are over here. With this, we completed basically the part programming, and into next webinars, we will show you additional features, which one you can basically minimize cycle time more, and it will be shown in the next webinar. With this, Sydney, I basically finish off. If there is any more questions, I'm free to answer.
Okay, thank you very, very much, Daniel. All I can say basically is just wow, because that's basically what Swiss type, way we do Swiss type is. It really, really looks easy, the way you've done it especially. And probably one of the most powerful applications that we have in SolidCAM today. There are no questions at this point. Again, everyone, the webinar has been recorded and will be available later on our website. So everyone have a great weekend, and we'll see you at our next webinar. And thank you again, Daniel.
Thank you very much, everybody. And thank you, Sydney. And
yes,
have a great day.
You too. Thanks. Bye-bye.
Bye-bye.